All right, this is lesson 12.4, the law of sines. The homework is actually going to be out of the textbook this time, pages 819 to 820. There's 6 problems there, 14, 16, 24, 28, 30, and 40, parts A and B. So I will also upload those 6 questions in a PDF in case you don't want to sign on to the online book. But those are your 6 problems that you'll have to do on a piece of notebook paper and upload them to Google Classroom. Make sure you show all your work. So the bell ringer there, I'm not going to really explain it, but in the law of sines, it uses proportions, and one way to solve a proportion is using cross products. So we'll get into that later on. So the law of sines, to find the area of a triangle, we know that the area formula is 1/2 the base times the height. In this case, in a trig function, if I'm looking at angle capital A there that's marked, if the sine of A is the opposite side over the hypotenuse, so that's the height over the hypotenuse there, so h over c. If I solve that for c, the height could be represented as c times sine of A. So then you can see there in the formula, instead of the h in the area formula, we can replace it with c sine of A. So the area formula that we would use here is 1/2 times the sides B and C, so lowercase means sides, times the sine of angle A. So basically you can use this formula for an area of a triangle if you know the lengths of 2 sides and the measure of the angle that's included. So there's 3 different formulas down here depending on which sides that you know. So it's the product of the 2 sides and the included angle. So if I know sides lowercase b and c, I can multiply those together, take half of it, and then multiply that by the sine of angle A. Likewise, if you know sides lowercase a and c and the included angle is capital B, you can take 1/2 times a times c and take the sine of angle B. And likewise for the last one. So let's actually use this formula. Example 1. Find the area of triangle ABC to the nearest 10th. So it's important to understand that you're rounding to the 10th here, and it gives you everything that you need. It gives you the 2 side lengths, A and B, and it wants to know what the area of this, if you know the included angle is 104 degrees. So in this case, I actually labeled my picture wrong. The 8 should be the A, and then 9 should be the B, but regardless, you're just substituting into the formula. So 1/2 should have been 8 times 9, or 9 times 8, times the sine of 104 degrees. So you can type that directly in your calculator. You can use a half or 0.5. Remember that your calculator must be in degree mode before you type this in, and round to the nearest 10th, so you get 34.9 centimeters squared. Also for area, keep in mind you need to remember to include the unit, and that unit is squared. So the guided practice, find the area of triangle ABC to the nearest 10th if you know angle A is 31, and B is 18 meters, and C is 22 meters. So those are the 2 sides, lowercase b and c. So we're going to multiply 18 by 22, take half of that, and we're going to have sine of my angle A of 31 degrees. So you type that in, you get 102.0 meters squared. And here is the law of sines that has proportions involved. So if you know side lengths, lowercase a, b, c, and you know some of the angles, capital A, B, C's, respectively, you can make a proportion with 2 out of the 3 of these. So you'll see in some examples that we do, but you can use this when you have the measures of 2 angles and 1 of the sides, or the measures of 2 of the sides and an angle that's opposite of 1 of those sides. So in this next example, it's going to tell us to use given measures to find all unknown side lengths and angle measures. So that's called solving a triangle. So you need to know all 3 sides and all 3 angles to solve the triangle. So example 2, solve triangle ABC, which means find all 3 angles, find all 3 sides. and round to the nearest tenth if necessary. So the first thing before I started labeling things on this triangle was, what is it giving you? So it gave you two angles, 80 degrees and 45 degrees, and it gave us one side, the 3. So early on in your schooling, you should know that 3 angles add up to 180 degrees in a triangle. It gave us 2 of them, so we could add the 80 and the 45 together to get 125. Subtract that from 180 degrees to find the third angle, which is 55 degrees. And make sure you put a degree symbol on that. So I found all 3 angles now. Now I need to focus on the sides, so we can use the law of sines. So I have sine of 80 degrees, and its opposite side is 3, so I can set up that as a ratio. Sine of 80 degrees over 3 equals, now if I want to find side length A, its opposite angle is 55. So you need sine of 55 degrees over its side length A. And here's where you can use cross products. So A times sine of 80 equals 3 times sine of 55. And if you want to solve for A, you have to divide both sides by sine of 80 degrees. Again, please make sure your calculator is in degree mode before you type any of that in. So you should have got the side length of A is 2.5. And likewise, I can set up a different ratio for side length B. So the angle that we're using here is capital C, sine of 80 degrees over its opposite side of 3. And then to find B, we need its opposite angle of 45. So sine of 45 degrees over B. And use cross products here. So you're going to have B times the sine of 80 equals 3 times the sine of 45. And I didn't show it, but you can divide both sides by sine of 80. So you can type that directly into your calculator and get 2.2 for side length B. So when you do your homework, I would find it helpful see how the highlighted answer is at the bottom, so everything's nice and neat. I can quickly see where your third angle is and your 2 other sides are. Next is an example with the answer shown. You can try that on your own to make sure you understand how to get those 3 values. Example 3. So this is if you know 2 sides and 1 angle. Round the side lengths to the nearest tenth and all angle measures to the nearest degree. So you're going to see that come up in all of these questions. So now I only had 2 of the sides and 1 angle. So instead of jumping right into finding the angle by adding them up, divide by or subtract by 180, I can't do that. So I need to start with the law of sines. So let's look at a ratio. The one angle that we knew was 105, and its opposite side is 9. So start that as a ratio. Sine of 105 degrees over 9 equals, now if I want to find side S, or angle S, I'm sorry, but I know its opposite side is 6, then you can write sine of S over 6. Because I didn't know that that was 40. That's what I drew in later. But to solve this ratio, cross multiply. 6 times sine of 105 over 9 equals sine of S. Now here's where it's a little bit different. When you take 6 times the sine of 105 over 9, it's going to give you a decimal. And obviously that's not going to make sense that that is the angle measure. So we actually have to take the inverse sign of that number. So I'm going to go to my calculator and show you how to enter this in. It doesn't really mean take that decimal and raise it up to the -1. So I'll show you on the calculator. I'm going to make sure my calculator is in degree mode. Then I'm going to make a fraction. I'm going to type in 6 times the sine of 105 and divide that by 9, and you'll get this decimal. So now I need the inverse sign. So you need to go up the blue button, the second, and then this. It'll give you a sine of a -1. Excuse me. Then go up and get your decimal, press enter, Press enter again, and you get 40. So that's how you find the angles using the inverse function. So angle S is 40 degrees. Now, since you know two of those angles now, 105 and 40, you can add those together, was 145, and subtract that from 180 to get the third angle, which is 35 degrees. So I have those labeled there. The last part I need to find out then is side length, lowercase t. So use another law of sines ratio with two fractions. The sine of 105 degrees over 9, its angle over its opposite side, equals the sine of 35, since we found that angle, over its opposite side length t. Use cross products. So we're going to multiply 9 times the sine of 35 and divide by 105. And we can type that directly in and get 5.3. So you have angle S is 40 degrees, angle T is 35 degrees, and side length T is about 5.3. Again, there's an additional problem there with the answer shown. You can try that for practice. And the last scenario, this is like a real life scenario. I know baseball players, the coronavirus kind of canceled that for you, but here's a baseball question. Use the law of sines to solve this real life problem. A baseball is hit between second and third base. So you see the players there trying to catch it at point B. How far from second base was the ball caught? So we know the two angles that were given were the 43 and the 65. We can add those up and subtract from 180 to get the missing angle at B is 72 degrees. And then I want to find side length between second base and the guy that's trying to catch it at point B. So I labeled that with an X. So then I labeled my other like points A and C, and then lowercase c and lowercase b. So you can use a ratio for a law of sines. So the sine of 43 over A, or in this case X, equals, and then the other ratio that we could use is sine of 72 degrees over the 90, because I know that side. So if you use cross products, you would take 90 times the sine of 43 and divide it by the sine of 72 degrees, and you would get about 64.5 feet. And then the guided practice, how far away from third base was the ball caught? So you would set up another ratio. So we know the sine of 72 over its opposite side of 90, and now we need lowercase c, so we need sine of 65 over c, that ratio. Use your cross products. Again, you would take 90 times the sine of 65 degrees and divide by sine of 72 degrees, and you'd get about 85.8 feet. So with those real life problems, make sure you put a unit on them. So that is the end of the lesson. I will upload these notes, and on the homework I want to point out on number 30, it'll say determine whether each triangle ABC has no solution, one solution, or two solutions. You don't have to do that part, just start with the directions of solving the triangle. So find the other two angles and the third side.